Hi guys, welcome to my abandoned classroom. I can show you, it's actually kind of sad right now. They're cleaning for the summer and my classroom is so sad and it misses all my students. Nice little show and tell, right? Now I'm dizzy. Woo! All right, so this was the first question that I assigned you about 2 weeks ago. It's the graph problem. So we're going to be tackling that one first. So let's take a look. Your question looks something like this. Yes? Cool. So in the intro, it says the graph of the continuous function g, the derivative of the function f. So this graph that we're looking at is the derivative of f. So remember that little trick I told you? They've told me that this is the graph of g. We know that g of x equals f prime of x. Boom, fact. With that, we're going to be able to answer these questions, and with that, we might score an extra point. Not an extra point, but a point. Okay. Then they've told us that we have this piecewise. It's nice and linear, so we've got some geometry shapes that we can deal with. But then we have this parabola at the end, and they've told us that the parabola is 2 times x minus 4 squared. So we're going to have to use that at some point. All right, so let's start with part A. On part A, they've given us that f at 1 is 3. That's position. F is the position formula since g is the derivative, which is velocity. So the position when x is 1 is at 3. What is the position at negative 5? So to figure that out, we need to know displacement. Displacement is the area under the derivative curve, or the area under velocity. So at 1, so right here, we know our position is 3. So we need to know the area all the way back to negative 5. Okay? So here we have a triangle. So 1 times 2 divided by 2, this has an area of 1. Here, no area, so that's nice. Here we have a triangle, 1 by 3. So 1 times 3 divided by 2, this is a negative 3 halves. And then we have a 3 by 3 box, which is negative 9. Okay, so this total area, negative 9, negative 3 halves, and a positive 1. Okay, 18, 21, 19 halves. Okay, so if we add all this up, we end up getting negative 19 halves. Yep, cool. So that tells me if we were at position 3 and we had covered negative 19 halves, where was I at negative 5? So what I'm going to do, I am going to take my 3 and I am going to minus my negative 19 halves. I'm subtracting because where did I start? And now I've ended at 3. So I'm going to end up adding those together, which ends up giving me a 25 halves. So if I was at 25 halves, the displacement was negative 19 halves, would end at me being at position 3. Okay, let me just double check that so I'm not lying to you. Sounds good. Okay, once we're done, I'm going to have to pull something up on my computer, but I'll be able to show you where those points would have come from to help you build your equations properly. Okay, part B, evaluate the integral from 1 to 6 of g of x. Again, Integral is similar to our displacement idea. We're just looking for the area under the curve. So from 1 to 6, we're going from 1 to 6. So this area is nice. It's a 2 by 2 box. So we can change that to 2. Sorry, a 2 by 2 box is 4. Goodness. 4 plus the integral from 3 to 6. This one's not so geometric. That's that parabola piece. So we're actually going to use the equation that they gave us here. So to evaluate this, it's going to be the integral from 3 to 6 of 2 times x minus 4 squared dx. You could FOIL this out and then antiderive, but because our function inside our function is just an x minus 4, what's the derivative of x minus 4? 1. So our chain rule is nice and simple, so we can go ahead and just integrate as is. So this ends up giving me, sorry, I've got to squat a little. Antiderivative, we're going to have 2 times x minus 4 cubed, add 1, divide by the new power. And we're going to evaluate that from 3 to 6. So I'm going to plug in 6. 6 minus 4 is 2. 2 cubed is 8 times 2. This gives me 16 thirds. Again, 6 minus 4 is 2. 2 cubed is 8 times 2 is 16 over 3. Then I'm going to plug in 3. 3 minus 4 is negative 1. Negative 1 cubed is negative 1 times 2. So we're going to subtract a negative 2 thirds. So the area under our parabola is 18 thirds. So this becomes 4 plus 18 thirds. That's 12. That's going to give me 30 over 3. So our integral equals 10. Yes? Okay? If you have questions, remember you can email me about any clarifying things. Also, if you find any errors, because we know I'm good for that, right? Okay. All right. And part C. Let me double check here. Where is f? Where is the original function f of x, concave up, and increasing? We know that f is increasing when we are above the x-axis. Positive velocity, negative velocity. Positive velocity means increase. Okay? Concave up means our derivative is increasing. So where are we above the x-axis and increasing? So that's going to happen here from 0 to 1. And then it's going to happen from 4 to 6. Okay? This is where we're above the x-axis and increasing. It says give a reason for your answer. So my reason would be g of x is greater than 0 and g prime of x is greater than 0. Above the x-axis, positive. Derivative of the derivative is increasing. Okay? You could also just say those are positive instead of greater than 0. Same thing. Okay, and our last one, D, where is the point of inflection? Point of inflection is where we see a derivative change from increase to decrease or decrease to increase. So, constant, increase, constant, increase, constant, decrease, increase. So we have a point of inflection at x equals 4, and we know that because g of x changes from increase from a decrease to increase. Boom, done. Okay, so again, I went quick. I'm talking to myself. It's very awkward. If you have any major questions, please email me. Let me real quick see what happens if I pull this up. Awesome. Sweet. Okay, so our answers here, if you set, so on this guy, I missed a point because I didn't set up the integral. The integral would have looked like 3 minus the integral from -5 to 1 of g of x. So I missed that point. There would have been the first point. Our answer would have given us our second point. Okay, part B, to know that our function was split here at 3, which I did here, that would have given me 1 point. The antiderivative of our function, which I got here, would have given me my second point, and then my answer of 10 gave me my third point there. Cool. Part C, we would have gotten our first point for our intervals, 0 to 1 and 4 to 6, and we would have gotten 1 point for our reasoning. And part D, we get 1 point for knowing that it's at x equals 4, and 1 point for our reason. And there's our 9 points. Okay, very cool. Hope that went through while I was on a different screen. Please email me if you have questions. I miss you guys. Hope you're doing good. Okay, bye.